Welcome to FrontEndSystemsLab. This is a channel where we explore what's really going on under the hood of modern web development. Today we are taking a look at Claude's new memory function integration and data structurization implementations. What if Claude actually remembered you? Not just your name, but your workflow, your preferred communication style, your active projects, the problems you are currently trying to solve, and the specific way you like information delivered to you. Every single time you opened a new conversation, none of that context would be lost. You would never have to re-explain your setup, re-establish your preferences, or remind Claude what you were working on last time. You would just pick up where you left off. That is the promise behind Claude's new memory function, and it represents a genuinely significant shift in how AI assistants can operate over time. But here is the question most people are not asking. How does that data actually get structured under the hood? What is being stored, in what format, and with what level of organization? And more importantly, can we as users and developers actually control any of that? Those are the questions we are going to dig into today, because the answers are more interesting and more actionable than most coverage of this feature. Let us start with the foundation, because a lot of people come into this topic with the wrong mental model. Claude does not have memory the way you have memory. There is no continuous thread of experience running between your conversations. By default, every single session starts completely fresh, a blank slate with zero awareness of anything that has happened before. If you told Claude your name, your job, and your entire life story yesterday, it has no access to any of that today. You are starting over every time. For casual use, that is fine, but for anyone trying to build a real working relationship with an AI assistant, using it as a thinking partner, a coding collaborator, a writing tool, or a research aid over weeks and months, that limitation is a serious problem. The new memory feature is Anthropic's answer to that problem. Here is how it actually works, and this is where most people's assumptions go sideways. The memory function is not recording your conversations and playing them back. It is not storing transcripts somewhere for Claude to search through later. What it is doing is something much more elegant and much more computationally interesting. At the end of a conversation, a model runs over everything that was discussed and performs a summarization pass. It extracts what it determines to be the key facts worth retaining. Things like your name, your professional background, your stated preferences, the topics you return to repeatedly, the way you like information presented, and the projects or goals you have mentioned. All of that gets compressed into compact, readable, natural language summaries. Not raw data, not token vectors, just clean, plain English statements about who you are and what you care about. Those summaries might look something like this. User is a backend engineer working primarily in Python and occasionally in Go. Or, user prefers concise, technical answers and gets frustrated by over-explanation. Or, user is building a B2B SaaS product targeting project managers and frequently asks about architecture and scalability decisions. Each of those is a discrete memory entry. They get stored, and at the start of your next conversation, they get quietly injected into the system prompt, giving Claude a detailed cheat sheet about you before you have typed a single word. From Claude's perspective in that new conversation, it is not discovering these facts for the first time. They are just part of its operating context. The pipeline, when you break it down, is 3 steps: summarization, then text storage, then context injection. Simple in concept, but powerful in practice. Now here is where the conversation gets technically interesting, and this is the part I really want to spend time on. Because if memories are stored as natural language text, they are by definition loosely structured. There is no enforced schema. There are no required fields. There is no guarantee of consistency between what gets stored from one conversation and what gets stored from the next. Claude might note your preference for short answers in one session using one phrasing, and then save a completely contradictory or redundant entry the following week using entirely different language. Without structure, the memory system can become noisy, inconsistent, and ultimately less useful the more it accumulates. So the real question is, can we impose structure on this? Can we define the shape of what gets remembered? And the answer is yes, on multiple levels, with increasing degrees of control depending on how deep you want to go. The first and most accessible level is manual memory editing. Inside Claude settings, if you navigate to the memory section, you can view every memory entry that has been stored, edit any of them, delete the ones that are wrong or outdated, and add new ones entirely from scratch. This is your most direct lever over the system, and it is more powerful than most people realize. Instead of waiting for Claude to auto-generate vague or inconsistent summaries, you can take over that process yourself and write memory entries the way you actually want them written. Rather than a memory that says something generic like user is interested in technology, you could write something precise and structured like domain, AI research, backend engineering, SaaS product development, or preferred response format, bullet points when listing options, plain prose for explanations, maximum 3 sentences per point, or active project, a B2B project management tool currently in private beta, targeting mid-sized engineering teams. When you write memories that way, with consistent labels, specific values, and clear categories, you have essentially defined a loose schema for your own context, and Claude will honor that structure when it reads those entries back. The second level is what I would call prompted structurization, and it works during the conversation itself. You can instruct Claude directly on how to format and categorize what it saves about you. Something as simple as telling it, when you store information about me, always organize it using these fields: domain, communication preference, active constraint, and current project. Claude will apply that framing going forward in that session, and when memory is enabled, carry that organizational logic into what gets stored. It is not a rigid database rule, and it does not come with any hard enforcement mechanism, but in practice, it produces noticeably more consistent and queryable memory entries over time. You are essentially training the summarization step to follow a template you designed. The third level is where things get genuinely powerful, and this is the level that opens up when you decide to stop relying entirely on the native memory system and start building something more deliberate on top of it. Claude's artifacts, the interactive outputs you can create directly inside Claude's chat interface, have access to a persistent key-value storage API that survives across sessions. That means you can build a custom memory manager as an artifact. A small application with a defined schema, structured fields, and its own read and write logic. You decide what fields matter. You decide what gets stored and when. You decide how the data is organized and how it gets presented back to Claude at the start of each session. A well-designed memory schema in that system might look something like this: user domain as an array of topic strings, communication style as a short descriptor, active project as a plain language summary, constraints as a list of things to always or never do, and a last updated timestamp. Every new session you load that object, inject it as context, and Claude operates with full awareness of your structured profile. You own the schema entirely. If you are working directly on the Anthropic API rather than through the Claude interface, your level of control goes up even further. The system prompt is completely yours to design. You can inject memory as XML tags with defined attribute structures, as JSON objects with typed fields, as markdown tables with labeled columns, or as any other format that makes sense for your application. Pair that system prompt injection with a simple persistence layer, a SQLite database, a flat JSON file, a Redis instance. Whatever fits your stack, and you have a fully custom memory architecture with whatever data structure you choose to define. You are not constrained by what the native memory system decides to store or how it decides to format things. You are building the whole layer yourself. The most advanced pattern beyond, that is what engineers are starting to call an agentic memory loop. In this setup, Claude is given access to a tool that lets it write to a memory store at the end of each session and read from it at the start of the next. The model itself is making decisions about what is worth retaining, how to categorize it, and when to update or overwrite existing entries. You are not just injecting context, you are giving Claude a persistent scratchpad that it manages autonomously. The model becomes an active participant in its own memory system, rather than a passive recipient of whatever context you choose to provide. This is where the boundary between a tool and a genuine long-term collaborator starts to get interestingly blurry. Here is the bigger picture, and this is really the point I want to land on. Memory is not just a convenience feature. It is not a quality of life improvement for users who are tired of repeating themselves. It is the foundational capability that makes AI assistance genuinely useful over time, rather than just occasionally useful in the moment. Right now, the dominant pattern for using Claude and really any large language model is what you might call the calculator model. You have a problem, you open the tool, you get an answer, you close the tab. There is no continuity between sessions. There is no accumulated understanding of your work or your goals. There is no relationship in any meaningful sense of that word. The interaction resets to zero every single time. Memory fundamentally disrupts that pattern. With a well-structured memory layer in place, Claude stops being a stateless tool that you pick up and put down, and starts behaving more like a system that actually knows you. It knows your goals. It knows your constraints. It knows the difference between a question you are asking because you are a beginner and a question you are asking because you are deep in the weeds of a hard problem. It knows when to be brief and when to go deep. It knows what you built last month and how the thing you are building now connects to it. That kind of contextual continuity is not a small thing. It is the difference between a generic response and a genuinely useful one, and that gap is enormous in practice. The underlying insight here is simple but easy to underestimate. The quality of an AI response is almost never limited by the model's raw capability. It is almost always limited by context. Give Claude more relevant context, and you get dramatically better outputs. Memory is just the mechanism for making that context persistent, for carrying it forward from one session to the next, so it does not have to be reestablished from scratch every time. The people who understand this, who take the time to structure their memory layers intentionally and keep them accurate and up to date, are going to get dramatically more out of these tools than people who treat each conversation as a fresh start. That gap in outcomes is only going to widen as these systems get more capable. So whether you are a casual user who just wants Claude to remember your name and your preferences, or a developer who wants to build a fully custom memory architecture with defined schemas and persistent storage, the tools are there. The native memory system gives you a starting point. Manual editing gives you direct control. Prompted structurization gives you consistency, and building your own layer gives you complete ownership of the data structure. Start wherever makes sense for how you use Claude today and evolve it from there. The investment is worth it.